NASA's lunar mining competition is for college students who build robots that can work on the moon. The objective of the competition is to collect the most moon dirt. Mechanical engineering professor Jeremiah Newbert is here to tell us about the competition. Thank you for being here today. So you placed very high in the competition. How well did you do?
Well, we actually placed #1 overall, and we placed second in the mining portion of the competition.
What awards did you receive since you placed so well?
For placing #1 overall, you get the Joe Cosmo Award for Excellence, and so that gets you a trip to Desert Rats, which is a lunar simulated base, and $1,500 for each student to go. And then we placed second in the mining competition, which gets you $2,500, and we also got tickets to go see the last shuttle launch. So that was very exciting for all the students.
Well, those are some big prizes that you get. Why did NASA put on this competition?
Well, NASA basically put on this competition for two reasons. So one being to get students to do some outreach. So as part of the competition, you have to do outreach. And the second thing was to also get some ideas about lunar robots. So part of NASA's mission is they want to go back to the moon someday. And so when they go back to the moon, they're going to need to make a lunar base. So to make a lunar base, they need to gather up lunar dirt or lunar regolith. So they have the regolith mining competition basically to get ideas from students. So the NASA scientists come down, they watch the competition, and they look at the robots and they see the different ideas that the students have, and then they take the best of those ideas, and eventually they're going to combine them together to make an actual lunar rover that will go to the moon.
It's like an ultimate robot. What does the competition consist of? It's not just the mining portion,
yes.
Is it?
It's not just the mining portion. So they have to do outreach activities. So they have to actually go to K through 12 schools and teach students about NASA and the competition. So they went to the Ben Franklin Elementary School and they actually worked with first graders, and they had about a week-long class where they taught about NASA and landing on the moon and what it takes to live on the moon. So students learned about all that. Then also they have to actually design the robot, which goes down and participates in the mining portion of the competition. And then a third part of it is actually to communicate what they did with the robot. So they have to do a paper, which is describing what they did, their design process, and then they also have to do an oral presentation at the competition, and then obviously the mining competition portion itself.
That's a lot of stuff going into it, and you place so high. How competitive is it down there?
It is very competitive. So many of the biggest universities and biggest, most competitive universities in the United States compete. So Harvard and Carnegie Mellon University. Also from Canada, they had McGill, which is one of the premier universities in Canada, and all these different universities come. Overall, there were 70 teams that registered for the competition. Of the 70 teams that registered, only about 35 showed up. The 35 that showed up, only about 30 of them actually moved once they got into the competition arena, and of that 30 that moved, only about 25 actually gathered any regolith at all. So it's a very tough competition.
So it's intense. We actually have the Lunar Bot here in the studio, and how does it work?
So basically what happens is that there is a computer inside the robot, and that computer actually runs all the different hardware on the robot, so it controls all the motors, so you can hear the motors there singing. That's the computer's communicating to those motors to move. And then there's another computer that actually communicates with the robot wirelessly, because the students actually can't view the robot during the competition, so they're sitting off to the side or in basically a separate room. So they have to use the cameras on the robot to be able to know where the robot is and how to mine the regolith.
You see that Joshua is actually controlling the robot with an Xbox controller. Do you guys just find stuff around your apartment or house, or is it a special remote?
So it's a basic Xbox controller, but the nice thing about it is that because it's a Microsoft product and Microsoft makes the operating system for the computer, they've included all the stuff you need to hook a Xbox controller right in the operating system, so it makes it really easy to integrate into the software that we built for the robot. And the nice thing about the Xbox controller is that, as all gamers know, they have tons of buttons on them, so we can map all the different functionality to the robot to the controller fairly easily.
So you also see this giant red button sitting on top. What is that? What does it do?
So the giant red button is for safety. So anyone who's watched movies about robots know it's always just a matter of time before the robots go berserk and start hurting people. So if this robot were to go berserk in the competition and go after a NASA person, they'd be able to hit the red button and it would stop the robot.
So it's a giant stop emergency button. What challenges did you face when you were down at the competition?
The most challenging portion of the competition for us was we ended up having to be one of the first, the very first team actually, one of two teams to go in the first round. And they actually had, the practice session was set up slightly different than the regular session, so we had to get the robot connected to the two computers that comprise the one that's connected to the controller and the one that's on the robot. We had to get those to connect, in a different manner. So we have 10 minutes to get that done, and it took us about 8.5 minutes. So we were really sweating towards the end that we weren't going to get those two to connect. So if they don't connect, you don't get to compete.
So high stress level, yes, right there at the very last minute. What made your design so successful?
Basically simplicity. So we really worked hard to make this a very simple and robust design. So there's very few moving parts on here, as few as we could make, and so that really helped us quite a bit. So it's not easy for sand to get in there and cause problems, or the lunar regolith to get in there and cause problems.
So real quickly, what can students take from this experience? They learn about integrating systems and working together. So one of the unique things about this program was that we had electrical engineers working with mechanical engineers, working with computer scientists, and that's something very unique. Not many schools offer an experience like that. So having all these people work together, they had to constantly negotiate with each other, because everyone wants something different. So each team has to negotiate, then get all those systems work together. That's quite a bit. Well, thank you so much for being here. It was great to have you.
Thank you for having me.